Hi, my name is Tyler Bukus, and I am doing Chapter 11, Steam and Hydronic Heating Systems. If you learn anything, this would be that thing. Steam and hydronic heating systems use steam or water to carry heat. Steam and hydronic heating systems heat water in a boiler at a central location and distribute the steam or heated water through supply piping to building spaces. The steam or heated water then flows through terminal devices that transfer the heat from the steam or water into the air of the building space. The steam or water returns to the boiler through return piping. So that's very important to know that you create it from a central location and it gets transported to the devices and then it returns. And we're going to go over a little bit more why and the things that do it. Steam and hydronic heating systems. Most commercial and some residential buildings use steam or hot water systems to supply the required heat. As you see here, you have a hot water heater and then terminal devices and supply piping, things like that. In a hot water heating system, the heated water is taken by a circulation pump through supply piping to heating units and returned to the boiler in return piping, as we discussed a moment ago. This chapter repeats a lot, so bear with. The next is boilers are located within a central mechanical room. They supply the steam or hot water. As you see there, you have two big old boilers there, and then you have your piping that goes out. It's kind of like a schematic of a boiler or a mechanical room. I used to call them boiler rooms, but a steam heating system. A steam heating system is a heating system that uses steam to carry heat from the point of generation to the point of use. Why are steam heating systems used? Good question. Steam heating systems are used because steam carries more BTUs, 970 per pound of steam than water, allowing steam to be used where there is a limited amount of room for the distribution system. It's a lot. Define steam and how it works. Whee! Steam is a vapor that flows anytime there is a difference in pressure from one area, the boiler, to another area, the heating unit or terminal device. Move that over there. So here's a diagram of a utility plant at the top, and then you have your utility tunnels to dorm A, dorm B, Hall A, Hall B, and then you have building X and Y and Hall C. And if you notice, the administration building has its own path as a utility tunnel. Everything else you could almost run in a full circle right back to the utility plant. The only time you'd have a special return line is right there at the administration building. Alright, so now we're in steam heating system components. Now, I realize this is a lot, and we're going to go over these components a couple of times throughout this presentation. First, we have the boiler. The boiler heats the water to above the boiling point to produce steam. Pretty little thing. Fittings. The fittings on a boiler and steam system provide safe and effective operations of the boiler. Accessories are the required systems and components to support the operation of a boiler, such as the fuel supply system and the feed water system, and a lot of other systems. But again, we'll go over those. Steam supply systems. Now this is a picture of our first tour of all the steam piping there. It is the piping and support system that provides a path for the steam flow from the boiler to the point of use. Here's a terminal device. Just an example of one, but it's one nonetheless. Heating exchangers terminal device transfers the heat from the steam to the medium, normal air, to heat a building space. So now we're going to talk about the location of a boiler. The location of a boiler should be on the lowest floor of a building. Again, if possible, but should be. Why is the location of a boiler so important? Good question. It is important to allow the hot steam to rise and the water to return without using pumps, if possible, for full efficiency. Now, as you see here, the flames going up, boiling the water, steam's being created, comes up the top, goes out, and then returns the water that once was steam and once was water prior to that. Here's another diagram of a boiler system. So you have your boiler, then you have your path, and as you see, it goes from heat rises, so it goes up to the top, hits all the units, the heating units, terminal devices, hits a steam trap because now it's going the opposite direction. So the steam trap prevents the steam from going the others back the way that it came, which then turns into a condensation back into the water. So now it's the return line, and then eventually, if need be, you have a feed water pump, and it shoots all the way back to the boiler, creating a cycle. If you didn't have the return, you'd eventually run out of the supply of water or whatever you're using to keep the boiler system from cracking itself and breaking itself in half. Alright, so now here is a hydronic heating system. A hydronic heating system is a heating system that uses water or other fluids to carry heat from the point of generation to the point of use. So in similar, there's some slight differences here. Where before you didn't have an expansion tank, here you do. Safety valves, you still have those, but also in here you have a control system. So it still creates the heat from inside, goes through the piping, hits your terminal devices, hits the return, and then goes into the circulation pump, and then Bob's your uncle, you have water again, or whichever fluid you're using. Hydronic heating systems contains So ASME, the American Society of Mechanical Engineering, breaks off boilers into 6 categories, and we're going to go over each. They break it off into low pressure heating, hot water heating boilers. As you see, the boiler in which water is heated for the production of supplying heat at pressures not to exceed 160 psi and temperatures not to exceed 250 degrees Fahrenheit. Then we have hot water supply boiler. It is a boiler having a volume exceeding 120 gallons, a heat input exceeding 200,000 BTUs per hour, or an operation temperature exceeding 200 degrees Fahrenheit. That provides hot water for use other than heating. So pretty much heating up water, not heating up, terminal units like a heater. Okay, so the next one is a power hot water. Now this is a high temperature boiler. It is a boiler used for heating water or liquid to a pressure exceeding 160 psi or to a temperature exceeding 250 degrees Fahrenheit, mainly used in large high-rise commercial buildings. Okay, so the next is low pressure steam heating boilers, and these boilers operate at pressures not to exceed 15 psi of steam. This type of boiler is used for heating pressures only and is normally used in residential or commercial buildings where steam is not needed for any other purpose. Power steam boilers. Okay. These boilers in which steam or other vapors is used at pressures exceeding 15 psi. And finally, small power boilers is a boiler with pressures exceeding 15 psi, not to exceed 100 psi, and having less than 440,000 BTUs per hour heating input. That is a lot of boilers. Okay, heating production, there are 2 options. We're going to go over fuel first. So fuel, you have your natural gas, your oils, your coal, and then they mix with air, oxygen, and they mix with an heating element, heat, and all 3 of those combined create a chemical reaction. That chemical reaction creates flame. Brr. Now, see that fire? That's the other one. That's a simple one. That's electricity. You flip the switch, and you have electricity. Turn it on, fire. It goes into more detail on it. There's filaments and a whole lot that dive into it, but I recommend that you go over that chapter because it is, or that section of the chapter on electric heat production, mainly because I don't have time to do it here, but it was pretty interesting how they broke down every little thing to create an electric boiler. Now, again, this chapter was huge, so I couldn't give you everything that's there. So I'm going to give you an opportunity to find it out on your own. So we have fittings and accessories. Fittings are components directly attached to the boiler and boiler devices. that are required for the operation of the boiler. Very important distinction. Accessories are components not directly attached to the boiler, but are still essential. Now, as you see there, I would go over them all, but then obviously I would go over the time limit that was given to us by the professor. So, instead, I gave you every fitting in the book and every accessory in the book that goes towards boilers. And let me tell you, it's a lot. But we will cover draft systems. A draft system is a boiler system that regulates the flow of air into and from the boiler burner. There are 4 types of draft systems. Number 1. The first is a natural draft. Is a draft produced by a natural action. So in a sense, you allow the atmosphere to produce your oxygen for you, so you don't have to like thrust it in there. So these aren't really common. However, if you look back in time where you have like a locomotive, a steam engine, well, they didn't have these jets pushing all the air in, and so it was more of a natural process to create the steam from the heat, and so forth. Number 2, a forced draft. This is a mechanical draft created by air pushed through the firebox by blowers located on the front of the boiler. So again, this is when we get into like feeding the beast with its oxygen. The next is inducted draft. I think I said that right. And again, it is where you are pulling air through the boiler's firebox mechanically, and you have blowers located at the breeching after the boiler. So fire, and it's just pushing the air, and it creates a much hotter boiler. And you gotta be careful on that, because too much heat, too much pressure, boom. Then you have a balanced draft, which again is still non-natural, because you have mechanical draft that is combining the forced draft and the inducted together, creating a balance between the two, so it burns more evenly. Alright, and now we are in hydronic heating systems. Accessories used in a hydronic heating systems include circulating pumps, expansion tanks, air vents, pressure reducing valves, and flow control valves. We're going to go over these 5. Bear with. We're almost done. So, this is a picture from our field trip. This is a circulating pump that was underneath the Centrum. I think that's what that building's called. It is a pump that moves water from the boiler through the piping system, through terminal devices, and then through return piping of the hydronic heating system. So it just kind of gives it a boost, helps everything keep moving at a steady pace. It's its job. Expansion tanks. Expansion tanks are vessels that allow the water in a hydronic heating system to expand without raising the system's water pressure to dangerous levels. So originally I was going to pull up a video of, Mythbusters where they sabotaged this aspect of a hot water heater and shot it through a roof, but ran out of time. Yeah, who am I kidding? Of course we're going to watch that. Just in case you didn't get that, Ricky Bobby, I'll show you one more time in slow motion. I now return you to your regularly scheduled PowerPoint presentation. So, pretty much what this does is it allows the excess water to fill up inside it. So it's kind of like when you are on a stove and you put a lid over your food you're cooking and it starts to boil and eventually starts to boil over. That's what this prevents your hydronic heating system from doing. It absorbs that pressure, absorbs that overflow, and fills it within its own tanks. The book covers a little bit more on where your requirements are, codes, and things like that. Air vents. Okay, so I found these kind of fascinating. So an air vent is an automatic or manual device that vents air from the hydronic heating system without allowing water to escape or air to enter into the system. So we learned in a former chapter of the airflow and how that was important. Well, because this is a self-contained unit, you don't want any extra air pressure, any extra water to kind of interfere with your system. But if you have to release some pressure, this is that thing that's going to help release but not let anything in. So the I used to call them as a plumber fart valves, but they would allow the air in but the gases couldn't escape. Someone will make a comment on what the AAV is, and we all should know it, but I think I got that question wrong. Just playing. So this is a picture of a dual system, one that's manual and one that is automatic, so if you're not near it. Each cap, I believe the black cap is the manual release and the red cap is the automatic. So if the pressure gets too high, it'll do its job whether you're there or not. Okay, so the next is the pressure reducing valve, and this pretty much takes the high pressures and converts it into a lower pressure. It pretty much just takes all the excess and keeps you from blowing up. Now, I also pulled this picture up because a lot of the fittings and accessories have a very keen distinction to them at the face. If you see at the part from the picture, there is an arrow. That means if you put this in backwards, it will not work for you. It won't do its job, and then you blow up. So remember, arrow goes with the flow, not against the flow. It's an important task to remember. Okay, so now we have the flow control valve. If the flow control valve is a valve that regulates the flow of the gallons per minute, GPM. I had to look that up. Of water in a hydronic heating system. Now, we ran into a couple of these guys down in the tunnel underneath the library, and these pretty much just make sure you're not just wasting water, but it'll help govern it to a point where, you know, it's manageable and not wasteful, and boosts efficiency and not efficiency or deficiency. We'll go with that. Okay, well, thanks guys for watching. You know, please leave your name, comments, things like that at the bottom of this, and truly appreciate all the hard work that we're all doing in this time of crisis, pandemic land of Corona. Okay, I'm gonna hang up now. Bye.